What's new in DDR these days? What's changing in terms of what the customers are asking for and how memory is being used?
There are a lot of similar requirements. I mean, they always go that really haven't changed. I mean, the basics are customers are looking for something to do the function that they need, right? That's very high level basic. But then there's the essence of what's behind it. You know, what the IP provider brings to the table, and in a lot of aspects of what I've seen, some IP providers tend to forget, and it ends up being, you know, reduce risk. It's obviously meeting their goals, you know, time to market, meet my performance needs, meet my area power needs, but then it costs a lot of money to develop a mask set today. So risk reduction is a critical aspect, even more so now than it was maybe a couple years ago.
What happens with memory as we start pushing down Moore's law into 28 nanometers and beyond? Is it still as easy to manufacture? Is it still the same old standby that you always had, or is it something changed?
Yeah, Moore's law is pushing the envelope for sure. Lots of things are changing. So the basics are still there. What the function is that the customer needs to do. Usually they want to go faster. But as you go down in technology, you know, with Moore's law, there are challenges, technology challenges in how we design the interface, how we design our products. And it's understanding those changes in the technology and the challenges and developing an IP that doesn't just meet the JEDEC specifications for DDR, for example, but meets the needs of the chip designer, meets the needs of the package and board designer. So looking at the whole system in totality and providing a solution with the backup behind it that helps our customers understand that, you know, we are experts in this field, and, you know, we're going to provide you, Mr. Customer or Mrs. Customer, a very reduced risk solution to help you get to market sooner.
The classic trade-offs of area, power, and performance really come into play in DDR, don't they?
They do, absolutely. In particular, DDR is an interface. You know, if I equate it to, you know, something like a SerDes, typically in a SerDes interface, it's a limited. It's more serial, so you don't have as many IOs interfacing off chip. But DDR, your bus width can 16, 32, 64, 72 bits wide. So absolutely, being able to contain the area is very crucial. And to your other question about power, the power in the interface is the largest portion of the power in the DDR interface is typically from the I/O itself. And so there are things that JEDEC is doing to help reduce the power, such as the LV DDR3, which is a lower voltage nominal supply, a 1.35 volt supply. So customers are looking for that to be able to manage that in their system. Because as we mentioned, technology is getting more challenging. It gives you a little faster speed, but with it comes inherently a little more power. Then we have to figure out how to manage that power. And then, you know, you get a little area reduction, but you have to figure out how to make it a better area solution.
Is DDR ending up in any markets that it didn't in the past? Is it starting to open up in new areas?
That's an interesting question. So I believe it is. So DDR has been the primary mode of off-chip memory for any system. So there was this whole aspect of SoC integration, or the name SoC standing for System on Chip, putting more and more contents on the chip. But inherently, there's a certain point where you can't put everything on the chip in respect to off-chip memory like DDR. And there are more applications that are requiring not just to use off-chip memory, but different types of off-chip memory. So you have cell phones, you have everything from digital television, set-top boxes. There's new applications that are coming out that maybe never existed before. Mobile video, everything that's portable, that you can take everything with you nowadays, everything through, you know, Wi-Fi connections and so forth. So all those new applications do absolutely need DDR. The PC space still probably dominates the volume of DRAM, DDR DRAM, But more and more applications are absolutely requiring more memory to run software-intensive parts of the solution.
We're going to start seeing DDR in things like industrial applications, automobiles.
Yes, actually we do today. So if you think of an automobile, I can't remember now, I heard a quote that there's like, I don't know, over 400 processors in an automobile. So you have GPS units, you have other things, everything's being built in, cell phones that are being built in, automated controls, sensing, different types of sensors and so forth. All of this technology needs software, and the software needs memory space in which to work in. So, yeah, and in addition to that, there's also automotive grade DRAM. So you have memory manufacturers that are designing and developing for DRAMs that have to run in a wider application range than before.
Luigi Ternullo, thank you very much.
Ed, thank you for your time. Appreciate it.